Have you ever wondered what the lives of the creatures living right under our noses are actually like? Because when we look closely at mosquitoes, we uncover the deeper and lesser known facts of their hidden world. From their weird underwater beginnings to their highly advanced internal systems, we can just let the information flow as we sit back and relax to explore these tiny organisms. To understand their ultimate success, we have to look at how they choose who to bite. Since a lot of people believe mosquitoes prefer individuals with sweet blood, when in reality, it is all about carbon dioxide and body heat. If there are multiple people sitting in a dark room, a mosquito will almost always target the one who is.
But even if we try to catch them, their unique physics make them incredibly elusive, since a mosquito's body is remarkably light and almost weightless. When it rains, a single raindrop is many times heavier than a mosquito and falls at dangerous speeds. Yet mosquitoes do not get crushed, because instead of resisting the impact, the mosquito simply relaxes its body and rides the air current pushed by the falling droplet. It essentially surfs the raindrop mid-air and slips right past it, completely unharmed. And this perfect biological design has allowed them to play a massive role in our planet's history. Have you ever thought about what would happen if mosquitoes completely went extinct? Because ecologists say that if urban mosquitoes disappeared, the ecosystem would barely notice. But if forest mosquitoes vanished, it would be an absolute disaster. Mosquito larvae are a primary food source for thousands of species of small freshwater fish and dragonflies. Plus, adult male mosquitoes do not drink blood at all, as they spend their short lives drinking nectar and accidentally pollinating wild plants, just like bees and butterflies.
What is even more fascinating is that mosquitoes actually have strict sleeping schedules, just like humans, where different species operate on highly organized shifts. For example, the Aedes mosquito works the day shift, being highly active during early morning and late afternoon before hiding to rest once it gets dark, whereas the Culex mosquito works the night shift, sleeping all day in dark corners and waking up the moment the sun goes down. Their work schedules almost never overlap, which shows a pretty sophisticated piece of time management, and it is honestly mind-blowing to think about how long they have been practicing these survival strategies. Mosquito fossils have been found dating back over 79 million years, meaning these tiny insects were flying around and buzzing in the ears of the Tyrannosaurus rex and Triceratops. Dinosaurs went extinct because they could not adapt to a changing planet, but the mosquito's basic biological design was so perfect that it survived multiple mass extinctions without needing a major upgrade, making them the quiet survivors of our world.
Beyond their history and survival skills, the actual engineering of a mosquito's body is a marvel of microtechnology. Because when a female mosquito lands on a surface, she utilizes highly sensitive chemical receptors on her feet to taste her surroundings before initiating a strike. Her mouthparts, which appear to the naked eye as a single needle, are actually a highly complex bundle of 6 separate specialized tools housed within a protective sheath. During a feeding session, this sheath bends backward, allowing the internal needles to plunge into the flesh, where 2 of these needles, equipped with microscopic razor-sharp teeth, rapidly saw through the skin to pave a smooth road, while another pair acts as surgical retractors, holding the sliced tissue open so the inner needles do not get pinched by the surrounding muscle. Once the pathway is clear, a 5th needle injects a heavy dose of saliva loaded with an evolutionary chemical cocktail that contains a localized anesthetic to numb the host's nerve endings, ensuring the process remains completely unfelt.
This fluid also introduces a powerful anticoagulant, which prevents the host's blood from clotting and keeps it flowing like a liquid fountain, before the 6th needle probes beneath the skin like a heat-seeking missile to puncture a capillary and draw the blood upward. As she drinks, her abdomen stretches into a translucent red balloon. And to keep herself light enough for a quick getaway, her digestive tract rapidly filters the blood to separate the nutrients from the water plasma, causing her to actively urinate the excess liquid out of her abdomen while still feeding. This toxic saliva left behind is the exact reason for the maddening aftermath of a bite, because the host's immune system quickly detects the foreign proteins in the mosquito spit and triggers an immediate defense response by flooding the area with a chemical called histamine. Interestingly, the itchy, swollen bump is not caused by the mosquito itself, but rather by the host's own body overreacting, since histamine dilates the local blood vessels to help white blood cells rush in and fight the intrusion, which inadvertently causes the tissue to swell into a red welt and irritates the nerve endings, where the more the area is scratched, the more the histamine spreads to magnify the inflammation.
Once the female escapes with her meal, she transitions into a master of evasion by retreating to the dark, forgotten corners of a room, under desks, inside closets, or against dark fabrics. She parks herself at a precise 45-degree angle and raises her back legs into the air to use them as ambient sensors that detect changes in air pressure and room vibrations. So if a human attempts to swat her, her body hairs register the compressed wall of air pushed ahead of the incoming hand. Within a staggering 1/100th of a second, her nervous system calculates the trajectory and commands a mid-air dodge, riding the very slipstream created by the attack. And if the room lights are suddenly switched on to hunt her down, the burst of light triggers temporary flash blindness in her compound eyes, prompting an immediate emergency landing on the nearest dark surface, where she remains completely frozen until her vision adjusts or the threat departs.
The social structure of these insects is equally unequal, because while the female operates as a highly calculated predator, the male mosquito lives a fleeting and delicate existence. Lacking the necessary needles to pierce skin, his larger feather-like antennae are tuned strictly to audio frequencies rather than the scent of blood, as he spends his short life hovering in large outdoor swarms, creating a mid-air acoustic grid designed to lock onto the precise wing beat frequency of a passing female. When a female enters the swarm, the male intercepts her and they mate mid-air in a matter of seconds. Where, following this single encounter, the female stores the genetic material in a specialized internal vault called a spermatheca. The chemical lining of this vault perfectly preserves the cells for her entire lifespan, allowing her to fertilize and lay hundreds of eggs across multiple cycles without ever needing to seek out another male, keeping them in a flawless and self-sustaining loop of survival forever.
The journey to maintaining this survival loop begins long before wings ever develop. The embryonic phase of a mosquito is a masterclass in adaptation. A female mosquito does not merely scatter her eggs. Instead, she binds them tightly with a specialized adhesive. This aligns them perfectly to form a floating structure known as an egg raft. Initially, these eggs are a pearly white color. However, they rapidly darken into a deep black within hours. This chemical camouflage allows them to blend seamlessly with murky, stagnant water. Yet, the true marvel lies in their sheer resilience. If their aquatic habitat completely evaporates and leaves behind dry mud, the development does not perish. The eggs simply enter a state of metabolic arrest called diapause. They can endure in a bone-dry environment for well over a year. They stay completely dormant, only to rehydrate and hatch within mere minutes of the next rainfall.
Upon hatching, the organism enters its larval stage. It transforms into a highly active underwater creature that breathes entirely through its rear end. Hanging upside down from the water's surface, the larva stabs a specialized respiratory siphon through the surface tension to draw in oxygen. Meanwhile, clusters of microbrushes around its mouth rotate at high speeds. This creates microscopic currents that vacuum up ambient bacteria, algae, and organic debris. Despite their constant feeding, these larvae are hypersensitive to external disturbances.
The slightest shadow or vibration triggers a rapid spasmodic diving maneuver toward the bottom. Because their bodies are naturally less dense than water, staying submerged requires continuous, exhausting effort. Therefore, they must constantly navigate back to the surface to replenish their oxygen supply, repeating this cycle thousands of times daily.
Following several molting phases, the larva transitions into a pupa, an intermediate stage resembling a heavily armored comma. During this phase, the insect undergoes a complete internal restructuring and ceases feeding entirely. Its respiratory organs are dynamically relocated from its posterior to its head, sprouting two trumpet-like tubes to breathe while floating statically at the surface. If threatened, the pupa executes powerful abdominal snaps. It darts away with a velocity significantly greater than that of its larval form. Within this static capsule, the muscles, compound eyes, and the intricate 6-needle mouth assembly are forged. When the transformation concludes, the pupal skin splits along the dorsal line. The adult mosquito then emerges into an incredibly hazardous transition. At this precise moment, its new exoskeleton is soft, its limbs are frail, and its wings are tightly crumpled. A solitary gust of wind or an untimely ripple can destabilize the insect, causing it to capsize and drown. It must remain perfectly poised on its own discarded pupal shell for several minutes. It relies on internal pressure to pump hemolymph into its wings to expand them, while ambient air hardens its outer armor. Once structural integrity is achieved, the young mosquito takes flight.
As they mature and spread across urban landscapes, these insects face heavy countermeasures from human civilization. This has sparked a silent chemical arms race. For decades, humanity has deployed synthetic neurotoxins like pyrethroids. These are designed to hijack the mosquito's nervous system, keeping its cellular sodium channels permanently open, resulting in immediate paralysis and collapse. However, evolutionary biology has enabled remarkable counter-adaptations. In densely populated cities, mosquitoes have undergone rapid genetic mutations. Certain strains have developed highly elevated levels of metabolic enzymes. These enzymes actively degrade and neutralize chemical sprays upon contact. Others have physically altered the molecular structure of their nerve receptors. This allows them to fly directly through toxic mists completely unaffected.
Even specialized repellents like DEET do not actually repel them through an offensive odor. Instead, they function as advanced sensory jammers. As these compounds evaporate from human skin, they form a molecular barrier that completely numbs the olfactory receptors on the mosquito's antennae. Upon landing on treated skin, the mosquito's thermal and chemical tracking systems completely malfunction. This renders her unable to recognize the warm blood vessels beneath. Confused and functionally blinded by the chemical interference, she is forced to abandon the host. She retreats back into the shadows to seek out less protected organisms, perpetuating a relentless cycle of survival that has remained unbroken for millions of years.
This relentless cycle of survival is not limited by geography or climate. The mosquito has mastered environmental adaptation across global extremes. In freezing northern wildernesses, entire generations synchronize their life cycles to survive harsh winters. Instead of dying off, certain species produce specialized biological antifreeze within their bodies. This allows them to endure sub-zero temperatures in a state of deep hibernation beneath frozen leaf litter. The moment the spring thaw arrives, they awaken simultaneously. They form massive, dark clouds that can quickly overwhelm local wildlife. In stark contrast, tropical species have adapted to exploit the microclimates created by human development. They utilize plumbing systems, potted plants, and discarded tires as permanent temperature-controlled breeding grounds. This completely decouples their reproductive cycles from natural seasonal shifts.
Their relationship with light is equally sophisticated and often misunderstood. Many flying insects are drawn to artificial light bulbs due to positive phototaxis. However, many nocturnal mosquito species utilize a completely different navigational strategy. They use the natural, ambient light of the moon and stars to maintain a straight flight path. They do this by keeping the light source at a constant angle to their eyes. When they encounter a bright indoor light bulb, their navigation system is disrupted. This causes them to spiral inward toward the source. However, once inside a home, they quickly abandon the light. Instead, they follow the subtle drafts created by air conditioning and ventilation systems. They track these air currents because moving air often carries the concentrated plumes of carbon dioxide exhaled by a sleeping host.
Once inside a structure, a mosquito behaves like a tactical ghost. She avoids wide-open walls, preferring textured surfaces where her camouflage works effectively. She hides in clothing racks, the undersides of wooden furniture, or the dark folds of bed sheets. Her flight path is intentionally erratic and quiet. She rarely flies in a straight line, making it incredibly difficult for the human eye to track her motion in real time. Even her signature buzzing sound is entirely functional. The pitch is produced by the rapid beating of her wings, up to 600 times per second. This sound is not meant to alert hosts. Instead, it serves as a short-range mating signal, allowing males and females to identify each other's specific species and frequency in total darkness.
When humans are not available, these insects adapt their hunting strategies to target a wide variety of other hosts. Different specialized strains focus on birds high up in the forest canopy. Others crawl into underground burrows to feed on sleeping rodents and reptiles. Some species have even evolved to feed exclusively on cold-blooded amphibians. They track the specific calls of frogs to locate them in pitch-black swamps. Regardless of the host, the biological exchange remains the same. It is a high-stakes theft of protein to fuel the next generation. The mosquito does not view humanity as an enemy, nor does it operate with malice. It is simply a highly tuned, millions of years old biological machine. It is quietly executing its programming, turning blood into life, and navigating the shadows of our world with absolute precision.
Mosquitoes are advanced biological machines, tracking body heat and using 6 specialized tools to draw blood. They can surf through raindrops completely unharmed and have outlived the dinosaurs for 79 million years, making them the ultimate survivors of our world. So thank you for listening and stay curious.